Ever scroll through Instagram and think, man, that AI filter really got my skin tone right? Well, get this. That same tech is helping doctors diagnose skin cancer,
Yeah.
like with crazy accuracy.
Yeah.
We're going deep on machine learning in medical imaging today, and trust
And
me,
it's not just sci-fi anymore.
you'll never look at a doctor's visit the same way again.
We're talking real-world applications, and we're going to unpack how it all works.
We've got some really interesting research lined up today, from the hardcore algorithms to the business side of actually getting this tech into hospitals and clinics. But before we get ahead of ourselves, let's start with the basics. Imagine like showing a computer a million pictures of lungs,
Right.
some healthy, some not,
Okay.
and it learns to spot the difference.
Yeah.
That's supervised learning in a nutshell.
It's like giving a computer a crash course in radiology,
Yeah.
right? We feed it these massive data sets of labeled images,
Yeah.
x-rays, CT scans, you name it. And the algorithms start picking up patterns, learning to tell the difference between, say, a benign mole and something that's a little more concerning.
And the crazy part is that sometimes these algorithms are even better at spotting those subtle differences than human experts.
Yeah.
I was reading this wild study where a machine learning model actually beat out a whole team of dermatologists at identifying skin cancer.
That study was huge. I mean,
Yeah.
that was a game changer.
Yeah.
Think about it. Faster, more accurate diagnoses, potentially catching diseases at an earlier stage when treatment is way more effective. I mean, that's the promise of machine learning in medicine.
Okay, that's mind-blowing. But how do these algorithms even work? Like, do they all learn the same way?
So think of it like a toolbox, right? You wouldn't use a hammer to tighten a screw, would you?
Right.
Different tasks need different tools, and that's where algorithms come in. There are tons of them out there, each with their own strengths and weaknesses.
So what are some of the, like, heavy hitters in the world of medical imaging?
One of the most common ones is called linear regression.
Okay.
It's a bit like, connecting the dots.
Yeah.
Except the dots are data points, and the line helps us make predictions.
So if you're tracking a patient's blood pressure over time, linear regression could help you see like a worrying trend, even if the individual readings seem okay.
Exactly. It's a powerful tool for understanding these relationships between different factors and then making predictions based on those connections.
Okay, that makes sense. But what about those really complex images, like the kind you see in radiology or pathology?
Right.
Surely it takes more than a straight line to make sense of all that data.
You're right. That's where things get even more interesting. That's where we start getting into like decision trees, random forests, and even neural networks.
Wow.
These algorithms can handle like way more complex patterns,
Okay.
making them perfect for analyzing medical images with super intricate details.
I've heard so much about neural networks. They're inspired by the human brain, right?
Yeah, exactly.
But how do they actually work, like in the context of medical imaging?
So picture a network of interconnected nodes,
Okay.
each processing information and passing it along to the next one. Each connection has a weight, and as the network learns, it adjusts those weights based on the data it's fed. It's like fine-tuning a symphony orchestra.
Wow.
Each instrument playing its part to create this like harmonious whole.
And in this case, the harmony is like a super accurate diagnosis.
Exactly.
That's wild. I have to admit, though, the idea of machines making such important decisions in healthcare, it's a little, I don't know, unnerving.
It's understandable to feel that way. The goal isn't to replace doctors, though.
Okay.
It's to give them superpowers.
Yeah.
To boost their expertise and help them make even better decisions for their patients.
Okay. That makes me feel a bit better. But like any tool, these algorithms are only as good as the hands that wield them.
You got it. And that brings us to a crucial aspect of this whole field: robustness.
Okay.
How reliable are these algorithms really, especially when they're faced with real-world data?
Right.
Data that might not be as clean and perfect as the data they were trained on.
So it's not just about creating these powerful algorithms. It's about making sure that they can, like, handle the unexpected, those curveballs that real-life medical practice throws at you.
Precisely. We need to be sure that these algorithms are going to perform consistently, even with variations in image quality, patient demographics, or even something as basic as the type of camera used to capture the image.
That makes a lot of sense.
Yeah.
So how do we ensure that these algorithms are up for the task? What steps are being taken to, like, build trust in these powerful but potentially fallible tools.
Well, that's where the real work begins. Researchers are developing all sorts of very clever techniques,
Okay.
from fine-tuning the training process to designing algorithms that are just inherently more resilient. It's an exciting area of research and one that has tremendous promise for the future of healthcare.
I am very intrigued. And I, for one, can't wait to dive deeper into these strategies for building more robust and trustworthy AI.
Get ready to have your mind blown because some of these approaches are straight out of a science fiction novel.
Mhm.
We're talking about training algorithms to anticipate the unexpected, to learn from their mistakes, and even to outsmart those who might try to, deceive them.
Okay, so we're talking about making these algorithms tougher, more adaptable.
Hmm.
But how do you actually do that? It feels like we're trying to predict the unpredictable.
It's a huge challenge.
Oh,
And one approach is to kind of fight fire with fire. So
right.
instead of just giving the algorithm perfect data,
Right.
we can actually train it on data that's been, intentionally messed with.
Wait, really? Like you're showing it blurry X-rays or something?
Exactly. Or images with different lighting, different contrasts.
Okay.
Even images where we've subtly changed some of the features.
Right.
By showing it all these variations, we can make it more robust to the inconsistencies it'll see in real world situations.
So it's like giving the algorithm a dose of reality. Like, hey, expect the unexpected.
Exactly. We call this data augmentation.
Okay.
And it's a key strategy for making these algorithms more reliable. We can also use something called transfer learning.
Okay, I'm gonna need you to break that one down for me. I
Okay.
need the ELI 5 version.
So imagine you've already trained an algorithm to recognize, say, different breeds of dogs.
Okay.
You've shown it thousands of pictures of, furry friends, and it's become a pro at dog identification.
Right.
Now, let's say you want to train a new algorithm, but this time it's to spot tumors in X-rays.
Okay, I think I see where you're going with this, but keep going.
Instead of starting from scratch, you can use the knowledge that your dog identifying algorithm already has. The early layers of that algorithm have learned to recognize things like basic shapes, edges, and patterns. Features that are actually relevant to any kind of image recognition, not just dogs.
So we're basically giving the new algorithm a head start. It doesn't need to reinvent the wheel.
Exactly. That's transfer learning.
Wow. Okay.
You're taking knowledge from one task and using it for a new but similar task. It's really powerful for improving efficiency and accuracy, especially in fields like medicine where data can be hard to come by.
That's amazing. But even with all these safeguards, there's always that chance that an algorithm could, slip up.
Right.
So what happens then? How do we make sure these systems are used responsibly and ethically, especially in healthcare?
That's the million-dollar question.
Right.
And it's something we have to keep asking ourselves as we, move further into this new territory. One really important thing is transparency.
Okay, so being super upfront about how these algorithms work, what data they were trained on, and any limitations they have.
Exactly. Patients need to know how these tools are being used in their care. And they should feel empowered to ask questions, to really understand what's going on.
And what about the doctors themselves? Are they getting enough training on how to actually use these tools effectively and responsibly?
That's another big piece of the puzzle. We need to make sure healthcare professionals have both the technical know-how to use these algorithms and the ethical framework to understand, the implications and potential biases.
So it sounds like a lot of collaboration is needed, right?
Oh, yeah.
Between the data scientists, the engineers, the doctors, the ethicists, even the patients themselves.
Absolutely. It's not just a technology issue, it's a societal one.
Right.
We all need to work together to ensure these tools are used for good.
Well said. On that note, let's shift gears a bit and look at a concrete example of how machine learning is already changing healthcare. I'm talking about radiology. Algorithms are helping doctors read X-rays and CT scans with incredible accuracy.
Yeah, this is where we really see it in action. Radiologists look at a ton of complex images every day.
Yeah.
And even the best can miss subtle things.
So it's like giving them an extra pair of eyes, basically.
Exactly. Imagine an algorithm that can pre-screen X-rays, flagging the ones with potential issues for the radiologist to check out closer.
Okay.
This saves time and also reduces the risk of human error.
That makes a lot of sense. Are there other areas in medicine where this tech is having a big impact?
Absolutely. We're seeing huge progress in ophthalmology.
Oh,
Algorithms are being used to detect diabetic retinopathy,
yeah,
which is a major cause of blindness.
right.
And in pathology, algorithms are helping to analyze biopsies and diagnose diseases like cancer, more accurately.
It's amazing how fast this tech is evolving.
Hmm.
What used to be science fiction is now a reality in hospitals and clinics.
Hmm.
But with all this talk of algorithms and data, it's easy to forget about the human side of things.
That's a really good point,
Right.
because ultimately, healthcare is about humans caring for other humans. And while these technologies can completely change how we diagnose and treat diseases, they should never replace that human connection, that doctor-patient relationship.
Well said. It sounds like we've got a lot to be hopeful about, but also a lot to be careful about as we move into this new era of AI-driven healthcare. But before we wrap up our deep dive on this,
Yeah.
I want to circle back to the business side of things.
Okay.
We talked about the science, we talked about the ethics,
Right.
but how is this actually being used in the real world?
That's a great question
Yeah.
because, developing a cool algorithm in a lab is one thing.
Right.
Getting it into the hands of doctors and patients is a whole other story.
Totally. So it's not just about the tech itself.
Right.
It's the infrastructure, the rules,
Yeah.
even the business models that need to exist to support it.
You got it. We're talking about this whole web of people involved,
Okay.
from startups and huge companies to, hospitals and insurance companies.
And they all need to be on board for this to work.
Exactly. It takes a team, and everyone needs that shared vision of how this tech can make patients' lives better,
Yeah.
while also making sure it's affordable and accessible.
So it's not just about building something new, it's about building a better system.
Right.
One that uses AI well,
Right.
but also keeps that human touch.
Yeah, absolutely.
You mentioned earlier that businesses need to find the right problems for machine learning to solve.
Right.
What did you mean by that? It's like they say, if all you have is a hammer, everything looks like a nail.
Right.
Just
Yeah.
because we can use machine learning doesn't automatically make it the best way to handle every problem.
Exactly. It's all about finding the right fit for machine learning, where it can truly shine, where it can,
Right.
really enhance what humans can do and tackle problems that we couldn't before.
So not replacing doctors and nurses, but making them even better.
Yeah, like giving them superpowers.
Right.
Imagine AI that helps doctors diagnose faster and more accurately. That frees up their time to actually focus on patients. Or AI that personalizes treatments
Yeah.
based on someone's genes. I mean, that's the kind of stuff that gets me really pumped about the future of healthcare.
Yeah, me too. But like anything powerful, we got to watch out for the downsides. Earlier, we were talking about robustness, right?
Right.
Making sure these algorithms can deal with messy, real-world data.
Right.
What other challenges should we be aware of?
One big one that's always coming up is bias. There have been cases where an algorithm trained on biased data actually makes those biases worse.
Oh, wow.
And that leads to, unfair or even harmful results.
Can you give an example? How does that bias actually show up in the real world?
Okay, so imagine an algorithm that's supposed to predict which patients would benefit most from a certain treatment.
Okay.
But if the data it learned from didn't include enough people from certain backgrounds, right,
Right.
it might accidentally learn to favor the groups that were well represented.
Oh, wow.
And that could actually worsen existing health disparities.
That's a scary thought. It really shows how important it is to have data that's diverse, that represents everyone. We need these algorithms learning from data that reflects, the whole human experience.
100%. And it's not just the data itself. It's also about who's building these algorithms, who's interpreting the results,
Right.
who's ultimately making decisions. We need a variety of voices involved at every level to make sure this tech is used ethically, and fairly.
So it's not just a tech problem to solve, it's a social justice issue too.
Exactly. And that's why it's so important to be having these discussions, to really grapple with the ethical side of AI
Yeah.
and work towards a future where this technology benefits everybody.
Really well said. So as we wrap up our deep dive into machine learning and medical imaging, I'm left feeling both amazed and cautious. It's clear this tech could revolutionize healthcare,
Yeah.
but we have to move forward carefully and enthusiastically.
I couldn't agree more. It's a balancing act for sure. But it's something we have to do together. And I am so excited to see where all this leads.
Me too. And to everyone listening, we hope this deep dive gave you a glimpse of the incredible potential here,
Yeah.
but also the very real challenges that come with it. This field is evolving so
It
fast.
is.
And as we all navigate this new world of AI-driven healthcare, your voices, your questions, your involvement are more crucial now than ever. Until next time, stay curious, everyone.